I have a review for you and some analysis of various Bluetooth codecs. For a while, some members have been interested in adding Bluetooth support to existing systems that don't have it. Specifically, some of them are looking for doing that in live sound and more professional applications. And I tested a couple of adapters there, and frankly, the performance was not all that great. So a suggestion was made to test a bunch of other ones, more consumerish brands, and I decided to get some of those. And today's one is a product by Topping called the BC3. It's a cute little device. It's shiny and feels good and substantial. Seller in China, AliExpress, sent this to me. Hopefully I'm pronouncing the name right. Is Yao Tiger Hi-Fi. I appreciate them sending this to me. The link is on the review. Anyway, this adapter actually has battery in it, so you can charge it with a USB connection on the side, and then it works portably, so you can take it to your car and what have you. The controls are touch, and so they don't have tactile feedback, even though they look kind of nice. One of the cool things about this that made my testing quite interesting and simple, and maybe I'll show you on the screen here, is the addition of optical output, digital output. So we can actually test the performance of the various Bluetooth codecs without worrying about the digital to analog converter on these devices. But I also tested that, and this device not only has line output, but also has headphone output. The digital Toslink output is a combo jack, and so you get line out analog and you get digital optical. There's a little adapter in there that converts that 3.5 millimeter connector to regular larger Toslink optical cable. So aptX is the original, one of the most common codecs in Bluetooth, and every time I test it, I see this really bad spectrum analysis. Here I'm just feeding the device a 1 kHz tone, so an ideal system would show this one peak over here with noise floor down to nothing. This again is a digital analysis, so there should be no analog noise, so the noise floor should just fall off the bottom. But it does not, and it's pretty far up here, and then it just truncates heavily and adds these other spikes. So this is a very simple signal, a 1 kHz tone. Any dumb compression algorithm should be able to handle this with ease. It's not complex, not noise and other things, but clearly it's not. And you can see the waveform on this left. It couldn't be simpler than any other music that you might play. The measured SINAD is only 67 dB, which is quite poor. Again, this is a perfect digital output out of this device, so if we had a lossless transmission, the SINAD would be through the roof. Switching to AAC, we see the same problem I've seen with other devices. Oh, I should mention that the source of the signal is my Samsung S8 Plus. If you turn on the developer options and go in there, you can actually select the different codecs in there. I'll get to Ldac. There's actually 2 things you got to do to turn on Ldac. But it's nice. You can go in there and select whichever one you want, and you can even select it while something's playing, and it'll dynamically switch, which is kind of cool. But you're basically at the mercy of the encoder that's in there. Everything that's the phone is producing is actually uncompressed, and a real-time encoder is compressing it into these formats dynamically. And whatever AAC encoder is in there is pretty horrible. I don't know if it comes from Samsung or it comes from Google, but it produces this really poor response. AAC is an advanced audio codec. It beats MP3 easily. At the data rates that Bluetooth provides, it should be a walk in the park for it to generate a pure 1 kHz tone. Not only does it not do that, it generates these sidebands, and then it generates all this garbage on the right. And I've seen this before from other devices, so I'm assuming it's a common problem to the encoder on Android. I apologize for not having an iPhone with AAC in there. Some I planned on doing for this review, but I forgot. So that'll come in the future. But for now, if you have an Android device, this is what you're going to get, which is pretty bad. Because its overall noise and distortion are lower, though, the SINAD improves. But remember that SINAD is a hardware measurement. Indeed, at some level we are testing hardware when I get to analog. But for now, it's not the best metric when it comes to fidelity. Actually, it's not a good metric at all when it comes to lossy codecs. But as a test of a hygiene, it's not bad to see what it did to a simple tone. SBC was the original music codec that was added to Bluetooth, we can see that its noise floor is high, so it actually gets a worse SINAD rating than AAC because of that. But it's actually pretty clean. You see the 1 kHz tone, and yes, you see some sidebands here and some spikes here. But to me, this is a cleaner spectrum than what we got with AAC up here. Indeed, I've done listening tests with the last device that I tested, and I thought the AAC sounded worse than SBC. In this case, I think SBC is using a much higher data rate than AAC. And because of that, even though it's not as sophisticated of a codec, is able to produce better sound quality on that. Now, something new is this Ldac codec. I've always seen the developer option to turn on Ldac in my Android phone, but every time I turned it on, it would turn right back off. Then I realized there's actually a second option under Bluetooth. When you turn on the Bluetooth in the Bluetooth options, for some reason the Ldac on-off is also there, so you have to enable it in both places, number one. Number two, it defaults to 16-bit mode, so if you turn it on, use it that way, and play the bits, you get an extremely good SINAD relative to the other ones, 97 dB, which is the limit of what you can get with 16-bit format. You get all these little spikes in here, usually start at 1 kHz, 100 hertz and go up. This always tells me that there's truncation happening from 24-bit test signal that I'm running to 16-bit. So we're actually screwing up the bits before we hand it off to the device. I can remedy that by going developer options and turning on 24-bit mode, which doesn't do anything for the other codecs, by the way. But on Ldac, as soon as I do that, look at what happens now. Look at how clean the spectrum is, and SINAD of 113 dB almost, which is phenomenal. I mean, this is extremely good relative to the, look at the garbage we've been dealing with here and here and here. So it finally does what Ldac at 24-bit, it does what it should be doing. I did a test for distance. There are different modes where you can set it to adaptive mode, where it'll switch up and down in bitrate depending on quality of the RF signal. I left it in the default, which is adaptive, and I assume as I increase the distance, it would switch down to lower rates and distort. Maybe it switched down, but I didn't notice it. I went as far as 25 feet. And this performance that you see was maintained. So very good. That was nice. I thought maybe just 1 or 2 meters that you get this kind of performance, but that was not the case. So now this is the digital output out of this little box, the BC3. How can you get this kind of analog performance? We're not going to listen to Toslink. So I hooked it up to a Topping D30 Pro DAC, Toslink out of this device, and then Toslink into that. And then I use the balanced output out of that. And we basically see the same performance, 113 dB. So end-to-end, over an RF connection, sending a 1 kHz pure tone, simple tone, we're able to achieve state-of-the-art up to 20, 30 feet over Bluetooth, which is remarkable. I mean, this is threshold of hearing stuff. Real music will be more complex, and that requires testing with listening tests. These kind of simple tests are not good. But as a baseline level, we see that there's only one codec in Bluetooth, one driven by Android at least, that gives us the transparency we're looking for. The other ones, I have listened to them. Like I said, all of them generate artifacts to my ears, with SBC being the cleanest, but still not nearly CD quality. I have not done listening tests yet with Ldac. I'll do that, but based on what I'm seeing in here, it's just numerically, it's extremely clean. Now, this little box also has its own analog output, its own DAC inside, and I measured that, and I measured it with the best DAC that we have, which is this Ldac, and we see the performance about 92, 93 dB SINAD, which is essentially just a hair below CD quality. So even the internal DAC in this is good enough that if you just want to listen to CD quality music, 16-bit, 44 kilohertz, is essentially good enough for that. And we can see that in dynamic range is 16 bits also. Ideally, you'd have the channel be much cleaner than the content you play, but waving my hands over it is good enough. It has headphone output. It's the same performance as line out, but probably has better drive capability. The output level is 2 volts. 2 volts is very good. Means it'll drive even high impedance headphones to reasonable volume on this thing. So post the review that I published, this came out yesterday, people asked for frequency response test. And I thought it was a good suggestion, so you're the first ones to see the frequency response test. I just added them to the review. I'm only showing you 2 of them at a time because all 4 of them on top of each other was hard to read. So first I ran an Ldac Sweep and it was basically, by the way, ignore this little wiggliness, the special kind of test that I use to run these kind of measurements generates a little bit of oscillation there. That's okay. But basically, it's from 20 hertz to 20 kilohertz. It's this pink line, hopefully you can see, is Ldac, and it's basically ruler flat to 20 kilohertz, which is the measurement limit of this test. SBC codec, it does very well flat, but then all of a sudden at 14.5 kilohertz, it starts to roll off. So there's some kind of filtering in there, and by 20 kilohertz, you're down 5 dB. So, how good are your ears, how young you are, whether you hear this or not, but it's a little unfortunate. This is a very common technique to get efficiency in lossy codecs because the high frequencies where all the noise is random, it doesn't have commonality with previous samples, which means it is harder to compress. It has higher entropy, as we call it. So if you just get rid of a little bit of the high frequencies, it helps compression efficiency tremendously. So, and that's what they do it. They chop off basically 20%, 25% of the, I don't know what that is, 15% of the bandwidth, but gives you much better quality for what's left in it. If it didn't filter that, then the mid bands would suffer a lot more, and that's where your hearing is most sensitive, and all of us hear that. So, it's a reasonable trade-off. Although since the competition, Ldac is able to do a flat response, question is, why couldn't SBC do the same thing? Hopefully you can see AAC in here is this green curve. It's very similar to the SBC one up here. I was surprised that it also filters starting at 15 kilohertz. I don't know what data rate the encoder is using in Android. Again, it's a real-time AAC encoder. How good his algorithm is. It's on anything at 128 kilobits per second and higher with AAC should provide response all the way up to 20 kilohertz. Why it's starting to roll off at 15 kilohertz? Maybe it's at lower bit rate. Maybe again they put a filter in there to make it easier to encode. I don't know, but it's bad. Clearly somebody didn't do this kind of objective analysis and caught these kinds of design mistakes. aptX, I don't even know what it's doing. It's just generating noisy output starting at 5 kilohertz, and really confuses this test by the time you get to 20 kilohertz. So it really tries to chop off all the high frequencies to benefit the low frequencies. This test, by the way, is a chirp sweep, which means it goes from low frequencies to high frequency, dynamic test. So when I run the dashboard, it's a 1 kilohertz that keeps repeating, whereas this test is actually dynamic. So codecs that rely on windowing and look at previous and next samples, they tend to see this as a more difficult test than the pure tones. And this kind of testing we usually use for headphone testing and speaker testing, where we run this sweep once and it chirps like a bird chirping, and then we get a bunch of data out of it. And one of the things that it spits out for free beyond frequency response is distortion plus noise. most of the frequency range that we're interested in this case 10 kilohertz. We see that the Ldac at the bottom is absolutely cleanest. It's not even a competition between Ldac and the other ones. It's distortion drops below minus 120 dB, below 500 hertz, so extremely clean. Above this, I was surprised that these three codecs, depending on frequency, they did something different. aptX just butchers the highs, as we already know, and some of the mid bands. But because it butchers all that, it tends to produce very good response in all of here than the other ones at lower frequencies. So to the extent you cared about bass and up to 1 kilohertz, maybe voices and things like that, is actually better than the other two codecs. SBC is sort of in the middle. It starts off decently, and then he gets really chewed up in here. Not sure what the heck is doing. It's got very frequency dependent artifacts on this thing. And then AAC is weird in that it's the worst in low frequencies, then it does better at the higher frequencies. So, but I don't know that this kind of analysis is all that useful, other than just a large distinction between these three codecs and then the Ldac, which stands on its own. Once again, I want to repeat that this is a simple test tones. We don't usually test perceptual codecs with measurements like this, but we take for granted that they can all produce a flat frequency response, and that pure tones don't bother them. The fact that pure tones bother these three means the implementation is broken, design's broken, something's really bad there. A bit about Ldac. It's a newer codec. It's not available on every device. It was invented by Sony, and Sony gives away the source code to Ldac as part of the Android open source. But that doesn't mean it's free. You have to go negotiate a license with them, and it's funny, they actually tell you it takes several months to negotiate a license. That's usually between two big companies arguing over a bunch of different gnarly things, and I explained some of the issues you could run into when you try to license these agreements. Essentially, the company that licenses this codec to you wants to make sure you never sue them, and that you can never sue anybody else that licensed it either. If you're a patent holder yourself, you don't want to agree to those just because you're licensing codec. You don't want to have all your other IP rights taken away. So you go through this, mating dance that can take forever and sometimes impossible to reconcile. Even the non-disclosure can be a major sticking point to sign. But once you've done all that, then you got to cough up money, royalties on a per device basis on that. Up here, I was surprised, pleasantly surprised that Topping is an official licensee and listed over here. I don't see companies like Samsung in here, for example. These Samsung and Sony are like oil and water. Maybe Samsung has some licensed Ldac in some products, but I'm not seeing it here. Certainly, you don't see Apple in here. Apple only wants AAC. I believe AAC patents have all run out, so it's free to them. If they put Ldac in there, they'd have to go cough up licensing fees, and given how many devices they sell, I don't think they're going to want to do that. Again, I'll test AAC at some point to see if it matches or beats this. Just as a side point, I'm an Android user, and I have an iPhone 6s that I got 6SE or whatever it's called, just for testing. I hate getting in it and doing things in it because I'm not an Apple iPhone user, so bit of laziness on my part, but I've got to unlock it and do some testing, which I will do. Okay, so hopefully you learned something about the different codecs in here. Even if you're not interested in this device, I actually found this project quite fun. These are all discoveries for me too. I hadn't measured Ldac before, and it was a very pleasant surprise to see the performance it has. So my recommendation is if you've got a phone, make sure you can generate Ldac, and for anything that receives it, see if you can get Ldac inside your DAC or whatever device you buy. But if you can't, this is only $69, so cheap enough, and essentially gives you transparent 24-bit performance on this thing. So it's pretty cool. You just turn on your phone, pull up your favorite app, and stream to this thing as if it's a desktop class, streaming. And, Bluetooth, at least on this, my experience with this, just plug and play instantly works. And like I said, this is also battery operated. So quite cool to get very, very high fidelity on the go, either out of its analog output or hook it up to another DAC with balanced output for live sessions and professional applications. Okay, so I hope you enjoyed this video as much as I enjoyed producing the review and the video, and see you in a future one. Bye-bye.